Okay, just conscious of time, so I'll just start the introduction now. So welcome to today's webinar, which is Estuary Edges, replacing brick, concrete and metal tide walls with a variety of habitats, which will be presented by Richard Charman, who is a geomorphologist in the Fisheries, Biodiversity and Geomorphology team at the Environment Agency. So the Estuary Edges project focuses on increasing the margins of mudflat, reedbed and saltmarsh along the edges of hardened, urbanised estuaries. Today, Richard will discuss the Tidal Thames Southeast UK case study, looking at the variety of methods which can be employed to soften estuary edges, the new how-to guide website, and why this softening is so vital to restore and preserve the ecosystem services they provide. So as always, there's a chance for you to ask questions at the end of the presentation. Please do submit these in the Q&A option at the bottom of your screen during any point of the presentation, and I'll ask these on your behalf. Just in case we run out of time to cover all questions, please make sure you add your name either when you've logged in or when you ask your question, and I can send these across to Richard by email for him to answer if we don't get time later on. So thank you all for logging in. I'm now going to hand over to Richard.
Hello, this is the fourth time I've given this presentation. The first time was internal to the Environment Agency, where we got sort of 100 people ringing in there. I've also presented to SciWem in recent months, and I've also presented to some graduate engineers who work in our flood risk function at the Environment Agency. So welcome to my living room. If you can see me in the top right hand corner, I can't see anyone's faces actually, so it feels very, very much like I'm not talking to anyone other than myself. The photograph you see on your screen is the O2 Peninsula in London. That would have been probably shortly after the year 2000. And now actually that front along by that section of the Tidal Thames has many, many flats, and that view would be quite different. But that was in the early days when that terrace was first created. And it gives you an idea of what I'm going to talk about over the next 30-35 minutes. Originally, there would have been large amounts more salt marsh or reed bed. In this particular location, you are beginning to move from reed bed, which would be the middle and upper estuary, to salt marsh plants, which would be in the lower estuary, i.e. closer towards the sea. But there will be other methods that I'll be talking about throughout the presentation. So as Rihanna said, it's about replacing brick, concrete and metal tidal walls. It's about urban environments. These aren't necessarily applicable to rural environments where we'd be looking at true managed realignment to try to get those habitats back. And not only does this have a positive impact on the ecology, on the plants, the invertebrates, the fish, the birds, potentially the contaminants. It makes the estuary side more accessible, greener, positive impacts on mental health as well. So we launched a new website in July 2019, which acts as a how-to guide on how to create these terraces, how to create these forms, aimed at developers as an influencing tool, effectively. There was an earlier version in 2008 as a set of PDFs, and they were less user-friendly, and we wanted something that would be more interactive. Actually, Rihanna, there is a poll that we spoke about. I don't know if that's still available, to find out how many people have actually heard of Estuary Edges already.
Sure, I'll launch that now for you.
That'd be amazing.
There we go.
I was expecting to see the results so far, but
okay, so far we have got 28% say yes and 72% say no.
Ah, okay, that's quite promising. I've had lower numbers with other. When do you close? Is that long enough?
I can close it anytime. Yeah.
Good. So that's probably long enough.
81% have voted. So we have got 25% that say yes and 75% who say no.
Okay, that's good news. That's good news. So that shows that the word is spreading. So the aim is I'm going around as many different organisations, chartered organisations such as this to spread the word. And I would ask you to spread the word after this, because the more people know about it, the more they'll point people to the website, the more they'll recommend it to developers, planners, local authorities, and we'll end up with more of them. My aspiration is that we would get all of the estuary edge changed to some form of what you're about to see in this presentation. Although the Tidal Thames in London is used as a case study, these principles can be applied to any urban, muddy, temperate estuary. Specifically muddy being because it's got a large tidal range. So you've got velocities that move sediment around. Temperate, well, that therefore forms saltmarsh and reedbed, whereas if we were in a tropical scenario, it would be mangroves. So a bit more about the Tidal Thames. It's 113 kilometres of tidal river from Teddington, which is at the point where the blue line on the map disappears near Richmond, all the way to the Isle of Sheppey. Where you delimit the exit of the estuary is up for debate, but the Water Framework Directive line is drawn from Warden Point on the Isle of Sheppey, near where you see Sheppey shown on the map. Much of the banks along the estuary have been hardened and modified, approximately 60%. Of the 42 kilometre central London stretch, so that's effectively where you see the Excel Centre shown on the map through to Richmond, only 1% has natural banks, and that's a location called Syon Park. That's opposite Kew Gardens, so that's worth a visit if you're ever there. And that 1% is only about 420 metres, so that's rather a sad statistic. All estuaries are very, very important wildlife superhighways, particularly ones where you've got large cities. It allows the movement of species through that urban area. It supports mudflats, intertidal foreshore, saltmarsh and reedbeds, as already mentioned, which are all priority habitats in the UK. Estuaries are very dynamic environments with tidal exchange, freshwater input, saltwater input, and those important conditions result in many species. They act as a nursery for and spawning area for many species of fish, such as smelt, which incidentally is also a priority species. In the Tidal Thames, there's 125 different species of fish and many rare or scarce species, such as the German hairy snail and the two-lipped door snail. For awareness, the Water Framework Directive has divided the Tidal Thames up into 3 water bodies, and the black lines delimit those on the upper map. So there's 2 black lines, and one is it's upper, middle and lower. So that leads us on to the Water Framework Directive. It's heavily modified for 2 reasons, one being flood protection, demonstrated by the Thames Barrier and by the lower level concrete defences in the bottom left, and navigation, which is demonstrated by the Dubai Ports London Gateway, which is not too far off Canvey Island in the photographs on the right hand side. What we want to achieve under the Water Framework Directive is as many mitigations as possible, as many enhancements as possible to bring back saltmarsh, but we can only do that within the limits of those 2 reasons for modification. So the navigation and the flood protection will still happen, absolutely, but the proposals in these slides are totally adaptable around that. Lost saltmarsh. So the photograph in the top right shows typically what happens with saltmarsh with sea level rise. You get a cliffing and lumps of saltmarsh breaking off and rolling across the mudflat. That photograph is courtesy of my colleague Mark Davidson, and that is in the Tidal Thames, I believe. Incidentally, it also shows Spartina, the invasive salt marsh plant, actually taking hold in the background, despite the old salt marsh at the front being eroded and rolling away. Sadly, we anticipate that since 1860, there's a loss of 10,000 hectares of salt marsh in the Tidal Thames through embankment construction and land drainage, and that actually excludes the fronting mudflats, so it's just the green bit. All of the areas in blue on your map that are highlighted through from where it says Thames underneath the photograph, and then up past Dartford through into central London, that would have all been some form of intertidal habitat, be it reed bed or salt marsh. Obviously, the upper bits would have been slightly more terrestrial, but they would have still had some species of plants that you'd find that can cope with regular inundation. So those two things, we've got the reclamation on the main map, and then we've got a sea level rise. So we are really running to catch up already, and that's without the pressure of a growing city on top of that. So the growing city, I think the photograph says most of it for you. Shading from bridges and buildings, lighting from bridges and buildings, extending land into the river, known as encroachment. We anticipate that the Tidal Thames is about 1/3 of its original size, although that's debatable. Dredging has resulted in a deeper, faster flowing channel with sharper, harder edges as a result of the concrete, metal and brick walls. So you've got a loss of your gentle gradients and your gentle edges, and that's what we're trying to put back in with the Estuary Edges work. Effectively, all of that results in a more hostile environment for life to cling on. Add on top of that water quality issues, loss of green open spaces next to the river, and then loss of brownfield habitat. This is a bit of a sob story, but that's where I'm going to stop the sob story and talk about what's possible. So the next 3 slides will show you how we've classified what we feel is possible in an urban environment. From the best possible, which is this naturalised setback. It's like a mini managed realignment, effectively, where you move your embankment or your wall further back, as shown by the bottom left-hand photograph, where a concrete wall at the front has been cut down and then a clay embankment has been built further back. Often those habitats have been lined with, in the construction stage, they've been lined with faggot bundles to help accrete intertidal mud quicker. All of these examples are in Barking Creek, which is the river Roding in East London. So the Barking barrier can be seen in the top right-hand photograph with the new creek that was created just inland of it. The bottom right photograph shows that once it's developed with a fisheries survey, the fish actually being captured in that survey in that blue trough. And then also in the top centre and top left are other creeks that have been created on the opposite bank of the estuary on Beckton Sewage Treatment Works land. And the bottom left is further up that creek, and that isn't one with a small creek created in it. It's just a softening of the edge in that style. So that's what we call naturalised setback. The Barking Creek mouth one in the top right-hand corner was completed in March 2006, and that was on Environment Agency land as a result of the Barking barrier. If that's not possible, there's not enough space, the developer doesn't want to give up the land, it's more important to have something else, there's utilities present, then intertidal vegetated terraces are the next best option, and they involve more engineering. I think something important to note with the naturalised setback is it has so little engineering in it that it should effectively last forever, whereas these options require some form of maintenance into the future. So we normally recommend that the design of this terrace, be it concrete, metal, timber, will last for the length of the development that's built behind it. And now that can be a challenge with timber, and therefore even with hard timber, they may well require replacement at some point during the development's lifespan. The examples you see on the screen are, top left is Wandsworth, the mouth of the River Wandle, which is in West London, so that's upper estuary, so very much fresh water. Then we've got the Greenwich Peninsula in the top right hand corner, which is part of the O2, the Millennium Dome construction that happened in the year 2000. You've already seen the photograph in the bottom left, that's around the corner from there. The central bottom photograph is a new terrace that was finished about maybe a year and a half ago at a development called Royal Wharf, previously known as Minoko Wharf, and that was just inside the Thames barrier. And we're quite pleased with that one because it integrates with a sustainable urban drainage system just inland of the flood defence, in that there's a swale designed to intercept fresh water, and then it allows it out through the terrace, which is probably the most natural way that it would happen in the real world. The bottom right photograph shows you Deptford Creek. There's a multi-tiered terrace created there. You can see the navigational markers put in place to prevent boats grounding on it. You can also interestingly see that some of the timber panels have fallen out. So if you look closely, you'll see that some of the vegetation is lower than the timbers either side, and that vegetation is growing out of soil at a lower level, and those timbers have fallen out. So that hasn't lasted the lifespan of the development. You'll also see that some of the sheet steel piles have got timbers cladded on in front of them at the back. So as much as possible has been done there to try to get some wildlife enhancements in place. Further to that, the red line in the top right-hand photograph, that's showing the route that's accessible for bottom-dwelling fish to be able to get up onto the terrace without going over edges. So bottom-dwelling fish such as goby and flounder have been found not to like to go over sharp edges. And therefore, with all of our terrace designs, we're often keen now to try to get them zigzagging. So there's a continuum from the fronting mudflat or gravel foreshore up into the vegetation. Now, actually, that top right example on the O2 Peninsula, that was an accident. It wasn't meant to be a zigzag, but the gravel that's been washed up and over the bottom levels and up over the top levels has formed that continuum. So now we actually recommend that design. So in the last possible scenario, where maybe you've already got a wall and you want to enhance the existing wall, or maybe there's a port and we're looking to get some mitigation around the corner from a dredge, it's possible to enhance the wall. And I think the bottom central photograph shows clearly the difference between a wall just with brick or concrete on it to the wall with timbers clad on it. All of these are in Deptford Creek, which is at Greenwich, to the west of Greenwich. So we're kind of on the border there between middle and lower estuary, so things are beginning to get much more saline. And the top right hand photograph shows they're not timbers that are infilled. Those are like window boxes effectively filled with rubble. The plastic strips on the bottom were designed to encourage sediment accretion. We now discourage plastic in our designs, so these have all been an evolution over time. The top left-hand photograph shows a wall that was rebuilt with new piles and reclad. and there aren't very many sections actually open to the open air. And so my flood risk colleagues, my engineering colleagues, we're currently going through the process of working out what is the bare minimum that can be left exposed percentage-wise, or what would need to be visible to an inspection of that sheet steel pile wall. Certainly where there's tie rods, so a rod going back into the bank that supports the fronting wall, they need to be exposed for regular inspection. The other thing worth noting on that is if you look up above where it says timber cladding on that photograph, you can see a sand bank that's been created for kingfishers or bees, burrowing creatures, maybe sand martins that could live in that wall. I think as far as we know, it's probably mainly occupied by burrowing bees, but I wanted to point that out because it blends in so well with the timber wall and the building above that most of the time it's not actually noticeable. So someone really did try to think outside the box with that design and come up with something that would tick so many different wildlife boxes. And as I said, they're all in Deptford Creek. So this was the 2008 documents, which weren't bad. They didn't have as many case studies, and certainly if you stumble across those documents, which are still in different places on the web, and I keep meaning to contact everyone and go through and tell them to rewrite their links. They were, however, a bit weak for influencing developers. They weren't, as I've already said, they weren't particularly interactive. And as new information had become available, as we'd learned things about the evolution of these sites, and we knew that some hadn't fared well, or we would tweak the designs. Of course, a PDF is not very easily updatable in that respect. So it's my biodiversity colleague's idea, Joe Heiss, to embark on a project run by the Thames Estuary Partnership, where we would rewrite these documents, bring in all that new information, do some new ecological sampling so that we had some more definitive evidence, make it more interactive, and then make it available to developers. So that project started in spring 2017, and it was run by the Thames Estuary Partnership by my colleague Amy Pryor, close partner, Amy Pryor. So these are the case studies. So we brought in more case studies, and we also made sure that they were all in the same estuary. Now, the original 2008 PDFs had mainly the Thames estuary and then a few from other estuaries, and I didn't think it was particularly consistent. The argument for having it all in one estuary is you've got the same pressures, you've got the same geography, the same geology. You can control in your experiment effectively much more. Now, within the different locations within the estuary, you've got some that are built on tributaries, so creeks effectively coming into the tidal Thames. You've got some that are on the open estuary, so they've got different energies in that respect, different wave energies mainly. Some are further down estuary towards the sea, so are more saline, some are further up estuary, and some are more urban and some are more peri-urban / rural. And if you take those combinations and add them all up, it makes something like 17. So we've ticked most of the different variations of those three elements. What do we do in that? Well, we looked at we measured plant, invertebrate, and fish diversity on and off 11 of the sites. We couldn't afford to measure any more, sadly. And another reason for doing this was to help deliver Water Framework Directive, and also to inform projects such as the Tideway Tunnel, the super sewer, and our Thames Estuary Asset Management 2100 project, which is the refurbishment and keeping going flood defences into the future. So this shows some of the sampling that was done. So bottom right photograph showing you our litter surveys, which were fairly rudimentary. We went to a site, walked around it if it was safe to do so, or stood on the bank and looked at the site and estimated whether it was high, medium or low for litter coverage. The bottom right shows the amount of microplastics, sadly, at Wandsworth in the top part of the estuary, the upper estuary. Top right photograph shows my colleague, actually, sorry, the guy in the blue hat I thought was my colleague Tom Cousins, but I don't think it is. Steve Coldclough is the guy with the red life jacket on the right hand side, and they're doing a fish survey in Deptford Creek with the same net. And then with your Fike net, which is the bottom left hand one, those are the ones that were deployed on the terraces to try to get an idea as a control on and off the terrace sites. So what did we measure? We measured, as I've already said, 11 sites with fish, 9 key sites with invertebrates, 9 key sites with plants. I'm a geomorphologist, so that's all about sediment accretion, erosion. So I went to all of the 17 sites and gave a review of where we could see washout of sediment had happened and where sediment had accreted above the original levels, and a basic survey of what plants had taken hold. Engineering was provided by our Team 2100 counterpart. He went to all 17 sites. Litter was all 17 sites. The Port of London Authority gave a review of navigational safety at all 17 sites. And then at 4 sites, the Thames Estuary Partnership spoke about, did a questionnaire on foot with people, pre social distancing, obviously, and spoke to them about how do they feel about these enhancements to the Tidal Thames. How did they make a difference for those people? So this was some of the results of that surveying. So the geomorphology, these are roughly sorry, no, they're not in order of upper to lower estuary. They're in a random order. They're in order of what's accreted to what's not accreted. So the upper estuary site at Battersea, which is the one with the red text in the bottom left-hand corner, that site is very steep. It's steeper than we would recommend, and we know more about the steepness of what succeeds now. Clearly, natural salt marsh and natural mudflats have a very, very gentle gradient. However, the steeper you can make it in reality, the greater the range of different vegetation types that you're going to get. So you're going to get some that would be representative of lower salt marsh and some that would be representative of an upper salt marsh. So Battersea, that steepness was incorporated, but sadly it means that if you've got a lot of wave energy, the sediment tends to get washed out, and that's what's happened there, unfortunately. Some of the better sites where that hasn't happened, West India Dock in the top right hand photograph, we anticipated it's about 97% of the site had accreted with sediment. Deptford Creek in the bottom right, 85% accreted. Most of the washout there is because of the drainage through the metal support at the front. And Greenwich Peninsula, where your original, the O2, the first slide that I showed you, that we think is about 75% accreted. So there's been some washout over time. So what do we find out about fish? Now, a very important thing about these surveys is they're only a one-off, and really they need repeating. So we've got, or we're hoping to have a legacy with this project that continues into the future, where universities will measure some data for us, but we're also recommending that developers will pay for further sampling into the future. And therefore, you can't really quantify. So I've put this as a general poor, good, moderate. Needs to be taken with a pinch of salt without further sampling. Battersea, we know that there's a floating boom, which you can see in the bottom left-hand photograph, which when that rises with the incoming tide, it's supposed to prevent wash-in of litter. But it also, we think, prevents access for fish, so it kind of defeats the purpose. On that site, in that one sample, there were 3 European eels, 1 bass, 1 common goby, and 2 roach. Greenwich Peninsula is our best out of all of those sites there. Very important, it hasn't really got an edge. There are locations where that edge has been cut down to the fronting mudflat or / gravel. Therefore, it's possible for bottom dwelling fish to get up onto it. And there was bass, common goby, thin-lipped grey mullet, flounder, eel, sand smelt, and sand goby, which is not too bad. Deptford Creek, which you see in the bottom right-hand corner, there was bass and goby found, but it's got a sharp edge. There's no, when that tide goes out, that photograph was taken from a boat. When that tide goes out, you've got a wall descending down to the mudflat, so there's no way for a fish to go up over that edge without feeling it as such. And West India Dock, which may have accreted well from the geomorphology survey, has very sharp edges. And it's very high up actually in the tidal cycle, so it's inundated fairly rarely, and therefore we thought the reason that 1 European eel was found there was related to that. Now, I will emphasize again, this is one survey. It's not really enough to make any concrete conclusions out of. So once we've done all those surveys, we got all this information together. We did some presentations, a bit like what you've just seen in the last couple of slides, and we locked a bunch of experts from Nigel Ponty, who's a fellow geomorphologist, through to my colleague Ian Humphreys, who is an expert on invertebrates, and we put them all together in a room, and we said, if there was a new website and we had a tick list for developers to go through to say what they should design their sites around, what would they be the most important things? And we called them design principles. And these are some of the design principles that are now, or that were considered. And I think, yes, these have all gone through onto the website. So they include approach multidisciplinary consultants to achieve a good product, use hardwood for structural elements so it doesn't deteriorate too quickly. Don't pre-plant unless absolutely necessary. So you expect your existing stock of reedbed or saltmarsh related plants to provide seeds into the other sites. In fact, I was on a conference call yesterday where someone asked a question about that, and I was able to use our Estuary Edges work to say that. Adaptability for climate change. That's a challenge, especially with the terraces, but we are suggesting that the designs are adaptable so that more boards could be fitted into them, for example, with sea level rise. That would allow the mudflat to accrete and grow up with the increasing sea height. Don't use plastic for obvious reasons, microplastics breaking off, contaminating the environment. Close to my heart, make sure geomorphology is a priority, because this is all about sediment accretion ultimately. So if it doesn't accrete any sediment, you're not going to get your vegetation, you're not going to get your improvement for wildlife and ecology. Zero tolerance for encroachment. We don't want any more encroachment. It's acceptable in very rare scenarios with mitigation, but we generally push back against it. Guidance on plant species for different parts of estuary. That's something we didn't actually achieve, but I'm hoping we'll be able to add at a later date. So this is what the web page looks like. Apologies, it's not readable. I had to shrink it down, but that's the classification drawing at the top, showing your naturalised setback, followed by your vegetated intertidal terraces, followed by your wall options, followed by your encroachment, and then an ecological value indicated at the bottom with a central drawing that's supposed to be like a schematic to show what that would be like in cross section. And then there's our 17 design principles underneath. So I was going to give you a bit more detail about some of the key design principles. the first design principle, funnily enough, is don't encroach. So design principle number 2 is always choose the design with the best ecological value practical within the site's limitations. It's a bit of a mouthful. Basically says do your best. So we've got again the same drawing that I've just explained in better quality in front of you. Design principle number 5. This actually shows Royal Wharf, which is the new development just inside the Thames barrier, and that shows the combination of the swale, which is indicated by the red dotted line, going out through the tidal terrace and then onto the mudflat. And we would like more sites like that, but they have to require very early consideration of the layout of the development. So the word being master planning, at that early stage where the planning starts happening and the building layout is going in, people like myself or my biodiversity colleagues at the Environment Agency need to be involved early to get it right. Another example where master planning goes wrong is elevation of outfalls or drainage. If they're too high up, you may get scour of the mudflat. Another example is too many tower blocks, too tall, too close to the edge, overshadowing a terrace design, and meaning that the terrace doesn't get enough sunlight and therefore won't flourish. It'll still form, it's very likely to still form some form of mudflat, but it won't have the vegetation that we would necessarily expect. Design principle 6, so now we're getting a bit more into the heritage recreation about the local environment for people. So look to your surrounding area to influence your design. So the example shown there, the bottom left-hand photograph is Strand on the Green, where a brick wall was rebuilt to include the right niches to help plants establish really quickly. At the O2 Peninsula, the Greenwich Peninsula, there was a sign put in on the shown by the top right photograph that talks about the improvements in the Thames and the different fish. And then you've got artwork as well. So there's an Anthony Gormley statue outside the Grapes Public House near the Isle of Dogs, which is shown in your top left photograph, which I took whilst enjoying a pint of beer one day. Design principle number 10. Design for geomorphology and design for litter. So I'll go on to show some photographs of litter in a moment, but geomorphology to start with. One of the things we've discovered is that if you've got a sharp corner in a terrace and you've got vessels approaching from a certain direction, you're more likely to get wave wash from those vessels. So the top schematic shows vessels approaching on one side of the estuary. The green blocks show where you've got some form of tidal terrace. It could be, could also be a bolted on timber. It could also be a naturalised setback. But the likelihood is that you're going to get washout in the areas indicated in red by waves. So we're suggesting we'll make sure those corners don't have sharp edges. Make sure they're curved, they're rounded, and they've got more riprap in them. That is also, incidentally, the corner where litter is going to be washed in. So what's happened at the Greenwich Peninsula, the bottom right photograph shows you the worst case, that end of that terrace, which is rather sad because that would have had sediment in it when it was first constructed, and it's washed out since then. And you can see the geotextile, the blue geotextile underneath. So we know with clever design that that ought to be possible. The rest of the terrace has worked well. It's just that end that you're looking at. So I know that photograph makes it look very bad. That takes us on to litter. No, sorry, the next slide will be litter. This is about slope angle. So I spoke about Battersea being too steep with open estuary sites where you've got more likely to have more wave energy. You're likely to have washout on the steeper slopes. So on a 1 in 7 slope where we've got our considering face, if it's open estuary and you've got lots of wave wash either from the wind or from vessels, 1 in 7 probably won't work. 1 in 10 would be much safer. A 1 in 4 is much too steep. So we've put this visually on the website as an indication. And there's the slide about litter that I was expecting before. You wouldn't have thought I've done this presentation 3 times before. So this was our basic assessment of litter. On the right-hand side, you've got a terrace in Bow Creek, which is the east, to the east of the Isle of Dogs in London, and that terrace is absolutely full of litter. You can bet that it's amazing the plants are managing to grow between the litter. It's rather sad. Now that design has groin structures almost along it, and one of the reasons we think the litter's got caught is because of those groin structures. On the left-hand side, you're back out in the open estuary. You're in the back on the O2, the Grange Peninsula. You've got much less litter. You've also got a gravel foreshore there because you've got slightly higher energy than the one on the right, which is a tributary and would be fine sediment. Design principle 13. I think I've hinted at this already. The lifetime of the structure needs to be the same as the projected lifespan of the development. Bit of a mouthful. Don't let your timbers fall out, and if they do fall out, replace them. So the drawing on the top right suggests what you could use softwood for, which could be the habitat timbers that are bolted on, but the actual structural elements that retain the fill, both for the high ground and the terraces beneath, need to be something that will last much longer. The bottom photograph shows what happens if you've got bolts that are used, and the bolt, eventually the timber rots around the bolt, the hole gets bigger, and those timbers are very, very easily falling off. So we've recommended using clamps, brackets rather, which would go around the timbers so that they hold onto them for longer. That also makes the Port of London Authority happy because they're less likely to get these timbers falling out and becoming a hazard to navigation. So we put all this on the website, and we launched it in July 2019 with a boat full of developers and a few consultants and a few environment agency staff, and we got people to talk, and we went past the sites and we mentioned what we were seeing. The weather was perfect. It went hitch free, so that was all good news. And in those photographs you can see my colleague Tanya Ferry at the Port of London Authority and Amy Pryor from the Thames Estuary Partnership. And the bottom photographs show Wandsworth and the O2 Peninsula, where you can see the massive tower blocks that have since gone up since the early days. There's the website. The photograph there is provided by the Port of London Authority. There's another photograph which I haven't been able to use because it's by a professional photographer. We haven't got his permission to use that on here. Please have a look at www.estuaryedges.co.uk. I need to give my regards to the different funding people. So the Port of London Authority paid for the website and are continuing to host it, very nicely of them. And that's been a lot of work. The Environment Agency put in the largest financial contribution to the project overall. Tideway provided a small financial contribution because the information from this was going to go into their terraces that they're going to build, or they are building, on the build outs. So there's been some encroachment as a result of the Tideway project, which overall will create a massive improvement in water quality. And on those small areas of encroachment, we're trying to get the best possible terraces. The Thames Estuary Partnership project managed, so thank you very much to Amy Pryor. Now there's a new lady, Eve Saunders, who's involved. The Institute of Fisheries Management, Steve Colclough, fisheries expert. He provided vast amounts of free advice and data well beyond his original contractual ask to do the fish surveys. All of the engineering at the different sites in terms of the assessment of how long timbers would last, how long sheet steel piles would last, was conducted by Jacobs under their remit, under our Team 2100, which is the Thames Estuary Asset Management 2100 project. So the legacy. We need more data. We need more data on these sites so that we've got more ecological information, and we haven't just got that one-off snapshot that I spoke about with our sampling earlier. In 2019, there was a new phase of Estuary Edges, which was originally called the Citizen Fish Project, where we were looking at citizen science. That was quickly discounted, that citizens couldn't do this work safely in an intertidal environment. So Eve Sanders went to universities, and we've now successfully got part of the University College London Aquatic Sciences Masters to include this in that. And there are some of the students from that on the foreshore looking rather cold, with Steve Colclough telling them how to do further fish surveys. And other universities are showing interest. So there's a long-term ambition to actually develop an estuary-focused degree course, which would be wonderful if that happens. 2020 onwards has kind of been halted to a large degree by COVID, sadly, but we were hoping to get a better rollout to developers with tools such as animations that show them what encroachment or what the reverse would achieve. So a video animation showing what could be achieved in a hypothetical environment, as well as improving further advice on climate change and understanding how a terrace could develop with climate change, because it's guesswork at the moment. And then for even further integration with academic research. Now, one of the questions that we may never get answered, the right-hand map shows, the green blobs show some of the terraces and features that have been created. That would be 5 years out of date now, so there's more than that now. That shows where features have been created, and the very small ones are bolt-on wall options, and the bigger bright green circles are the terraces, and there aren't actually any naturalised setback in this part of the Tidal Thames. The question is, how many of these features do we need to reach ecological potential for Water Framework Directive, good ecological potential for the Water Framework Directive? So I've coloured in these other dots, the kind of browny grey ones, that could be hypothetical future ones, and we don't really know what the ecological overlap is between these different spheres, these different circles. So how many pearls do we need on a string to link up and allow the biology to flourish? There is my colleague Joe Heiss, bottom right hand corner, whose baby this project was, and myself. We're standing on the terrace at Wandsworth, having done the litter survey and the geomorphology survey, and that's really all I've got to say. So